Welcome to another explainer brought to you by Forge College. Today, we're tackling a massive topic in our From EVM to SVM track, picking up right where we left off with design patterns for reusable token programs. But here's the multi-million-dollar question for you. Once your program is actually live, how do you change it? Seriously, how do you renovate a towering digital skyscraper while thousands of users are still living inside, trading, and heavily relying on your code? Well, today we're diving into the lifecycle, upgrades, and exactly how we prepare the ground for heavily regulated security tokens. Here's our blueprint for today. We'll be looking at the upgrade dilemma, executing the blueprint, migrating state safely, documenting the disaster plan, the master key, the rollback plan, and finally, next stop, security tokens. All right, let's jump right into section 1, the upgrade dilemma. Now, if you're coming over from the EVM world, you're probably used to the idea that code is law, right? Smart contracts are permanent. But Solana, it solves this natively through something called the upgradeable loader. Instead of hacking together these really complex proxy contracts, this native mechanism literally lets developers swap out the program's binary code, essentially the foundation of our building, without actually dropping the building itself. Your on-chain state remains totally preserved, and it's all governed by an explicit upgrade authority. It's an absolute game changer. Moving right along, section 2, executing the blueprint. So how do we actually pull this off without bringing the whole system down? Well, consider this your mandatory safety briefing. Here's our strict 4-step deployment process. First, we deploy the initial program. Second, we take a snapshot of the state, because we need a baseline, right? Third, we upgrade the binary using the exact same program ID. And fourth, we verify our checksums to make absolutely sure nothing broke. And guys, I literally cannot stress this enough. You practice this on devnet first, because if you do your very first upgrade on mainnet and accidentally zero out everyone's token balances, well, you're going to be instantly updating your resume instead of your code. Okay, section 3, migrating state safely. You see, updating the code binary is really only half the battle. You also have to make sure the furniture inside still fits into the new rooms. There's a big difference between what can change and what absolutely cannot. Raw bytes, like the literal cryptographic hashes of account data, are naturally going to change during an update. That's fine. But your semantic invariants, these are your load-bearing walls, things like token balances and owner public keys, those must remain perfectly identical. If an upgrade suddenly changes a user's balance from 1,000 tokens to 0, yeah, the building just collapsed. Which leads us to this kind of terrifying question. What happens if the upgrade corrupts the state? Imagine pushing an update at 2 in the morning, and suddenly all those semantic invariants we just talked about are overwritten. The data is completely scrambled. That is the absolute worst-case scenario in Web3, and it is exactly why we have to build incredibly rigorous migration paths. So to prevent that 2 a.m. nightmare, we follow this golden rule. Always make migrations idempotent and guarded by explicit version checks. Now, if you're not familiar with the word idempotent, it basically just means that if you run the exact same process twice or even 10 times, it won't change the result beyond that very first application. You definitely do not want to use your clicking migrate twice and somehow doubling their balance or worse, totally corrupting their account layout. Explicit version checks are what stop that mutation dead in its tracks. To execute this safely, we use something called a migration entry point. Think of it as a specific, highly secure bridge that's baked directly into your new program code. It takes your users' highly valuable data from the version 1 structure, safely walks it across the bridge, and slots it perfectly into the version 2 layout, all without duplicating or destroying a single thing. Which brings us to section 4, documenting the disaster plan. Look, security auditors are not just going to take your word for it that an upgrade went fine. They want the receipts. They want the operational playbook. So here are these specific CLI commands they're going to demand to see. First, running Solana program show proves that your program ID is unchanged and the upgrade authority is correct. Next, comparing the JSON output proves semantic equality, meaning the balances actually match. And finally, running that migration twice tests the idempotency, proving the version field remains absolutely stable. Trust me, having this debug report is your ultimate defense when a security audit comes around. Next up, section 5, the master key. So, who actually holds the power to push these upgrades? Well, over the lifecycle of a project, this changes. On day 1, you're deploying locally using a vulnerable developer key pair right on your laptop. By day 2, you're running simulated upgrades on devnet. But by day 3, right before you even think about touching production, you absolutely must execute an authority rotation. Using the Solana program set upgrade authority command, you hand off that immense power to a highly secure hardware module or a multi-sig wallet. All right, Section 6, the rollback plan. Because let's be real, even with all the devnet practice in the world, the best engineers still make mistakes. So you have to map out an emergency exit. When an upgrade goes sideways, don't panic. First, identify the breaking bug. Second, locate the stored binary buffer of the old working code. And third, redeploy that old binary via the upgradable loader using the exact same program ID. You revert the logic, save the data, and basically you save the day. And finally, Section 7. Next stop, security tokens. So why are we being so obsessed with rigorous debug reports and testing rollbacks right now? We're doing this because setting up these bulletproof life cycles is the mandatory prerequisite for what comes next in this track. By establishing these robust upgrade practices, we've minimized the risk of accidental token loss. And that means we are now ready for heavy compliance-grade controls. In our very next explainer, we're going to introduce ERC 3643 security tokens to Solana. We are talking about freezing assets, revoking tokens, and implementing strict transfer restrictions. You simply cannot build those kinds of high-stakes features on a shaky foundation. Which leaves us with this final provocative thought. Are your program foundations actually strong enough to hold the weight of compliance-grade security tokens? I really hope that after today's walkthrough, your answer is yes. To master these Web3 concepts, run through the labs, and get hands-on with the code, make sure you visit forge.college. There is an absolute wealth of knowledge waiting for you over there. Thank you so much for joining me on this explainer created by Forge College. Keep building, keep testing on DevNet for sure, and I will see you in the next one.